He said you had to divide, so that's saying that would go down to this here.
You live with your mom?
Yeah. No.
From where?
From my house to mom's,
Oh, no.
it's 26 miles.
Do you have to divide in the equation?
How many kilometers?
I'm dividing it out right now. Watch me and Riley divide. You two would be the only ones, I think.
There are 1,609 meters is 1 mile. What do I write first?
You write 26 miles. And then you put 1,609 meters over 1 mile. And then you cross out miles. And then you do 1 kilometer over 1,000 meters.
Yeah, you need to divide. Wait, why would it be over 1,000? Why would it be 1,000 over 1?
Because you've got meters. Meters cancel out this way. You are. I am capturing this on video, guys. Just so you know.
Riley.
All right, so somebody do the arithmetic. I believe Riley did it.
41.834.
41.834 kilometers. Okay. How many significant figures are there in my one measurement? 2. How many does this need? 2. So what is my answer?
41. 42, my bad. You have to run that.
Alon, we
weighs 245 newtons, and the area covered by the solar release is about 169 centimeters squared.
That's almost the same answer as it was on our test or on our quiz.
Standing up, what pressure does he exert on the ground in Pascal?
A lot.
Okay.
Solve it.
So on the quiz, or in this case on the exam review, or hint, on the exam, you will be given the information that 1 Pascal is 1 Newton per meter squared. Okay, solve the problem. 45 newtons.
Cooper, what'd you say?
Negative 1,000? Nope.
And her feet cover 169 centimeters squared.
Wait, here's the.
All right. So how do I get this? Remember, if we're going for pascals, we need newtons per meter squared, right?
Yeah.
Okay. So what do I do first?
What I did was 100 centimeters over meters.
Okay.
And then that again. And
Guys,
then
hush.
what I did.
You can just multiply. So you end up with 245 with 4 zeros after it, divided by 169.
2,497 is what I got.
You beat me.
And then behind the decimal is 0.4142.
Okay, we don't need all that. So how many significant figures does this have?
3.
How many does this have?
3.
How many does this need?
3.
So she exerts,
Exact same answer I got.
what, round this to 3 significant figures?
13,500.
Wait.
What?
It was 14, not
Wait,
13.
how'd you get that?
It's 14,000.
Oh, 14?
Yeah, that's what I thought.
Yeah, it's
It's 14.
14,500.
No, it's not. It's
No, it's
13,000.
It's,
So did you get that right?
wait. I got
No,
I
it's
got
not.
Okay, now Brandon, what you did was this. You took 169 centimeters squared, 100 over,
Yeah, but isn't that the way you showed it?
uh-huh. Okay, and then you get 0.0169 meters squared, and then you divide. That's fine. You can do it that way. 245 newtons divided by.
So what you do is 245 times 100 times 100 divided by 169.
I'm worried about Hunter.
No, we got it in Mrs. Paul's.
This Paul is
Getting it out.
And then we
It's like
put
I'm
it
worried
in
about the
scientific
Smith.
notation.
You guys do know that you're being recorded right now, right?
Yeah.
Okay, in scientific notation, we always want the decimal where? Just to the right of what?
The one number.
The first number. Okay, so it's 1.45 times 10 to the what? 1, 2, 3, 4. Good?
Yeah.
189 newtons to give blood. Emily has a mass of 47 kilograms, and acceleration due to gravity is 9.8 meters per second squared. Remember, force equals mass times acceleration. Okay? But you really don't even have to know that because this is provided to you. And so you know that you have to multiply kilograms times meters per second squared to get into the right units. Okay, same thing with the Pascal problem. You know by looking at it, you've got to get newtons divided by meters squared in order to get your pressure. So by knowing the right units, you know how to do the problem. This is a simple multiplication problem.
I'm 40,
First one in this room.
460.6.
You hit the car.
Wait, do you have to round up on the airplane?
So does she weigh enough?
Yes.
No.
Do you have to
No.
round up? She just has to put like a pillow under her shirt and some like extra
She
socks.
just has to wear ankle weights.
Who wants to give, I mean, you don't want to give blood if you don't weigh enough because you will pass out and it will be uncomfortable.
Like if you lock your knees in long enough.
Yeah,
Oh.
like that. Okay, so
Great.
this is what you get if you multiply those two numbers. Now, the next question, Hunter, says put it in scientific notation. So even though the real answer to this question is no, you still need to look at this and make sure you've got the right number of significant figures and that you have it, that you know how to put it in scientific notation. So how many significant figures in 47 kilograms?
2.
How many in
3.
9.8?
2.
Okay, so how many does this need?
2. So 470. 460.
You're comfy.
My bad. I don't know why I rounded up.
461.
4.6
460
times
460
10 squared.
Because two significant figures equal. So that equals 4 what?
4.6 times 10 squared.
Parker, stop playing.
Don't forget the end.
All right, just like Hunter just said, don't forget to put units on the scientific notation problem or you will get it half credit.
No, then you only get 1 point.
Then you would only get 1 point, and if you don't have the right number of significant figures in it, even though it is a scientific notation problem, you will lose another point. So you could get 0 credit on it, even if you know how to do scientific notation.